Okay, a one-tailed version of the same problem. Just like every time we've done this, it doesn't change the data any. We're just changing our predictions about that data. So we have to rewrite the predictions, and we'll have to recheck our critical t values because now we'll have all 5% pushed together. But we know that step 3 will be the same, and we'll just have to see what happens in step 4. So this problem that I pulled out of a previous version of a textbook, previous edition, doesn't have a story problem. It was meant to be run two-tailed. So I'm going to have to make up the story problem, if you will. We don't need the story element of it, but we need to know what to predict. So we are going to predict that the treatment is going to cause scores to increase. Whatever this treatment is and whatever these scores are measuring, we're predicting that the second set of measurements should be higher than the first. Scores should go up. So as always, what we end up doing here is just having to swap out the symbols that were written in there before. So for the two-tailed version, this says doesn't equal and that says equal. Well, this is talking about the average, the mean of the different scores for the population. If we're expecting scores to go up, different scores will be positive, which means the mean of those different scores will be positive. And positive numbers are greater than 0, right? Or, as always, if the treatment is predicting scores will go up, we know it's got to be a greater than sign. Scores will be greater than they were. So the null, as usual, is less than or equal to, since we've got a greater than at the top. So same strategy we've always done. Just take out the signs and put these new ones in. As always, if we were predicting that scores would make that the treatment would make the scores go down, like lowering blood pressure or something, then we would write less than. The scores would be less than they would have been. In step 2, it's now a one-tailed test. The alpha level is still 0.05. Our degrees of freedom is still 5. But because it's one-tailed, we've got to look it up. So again, make sure you're using the top header for one tail over to 0.05, down to 5 degrees of freedom. And now you should find that the critical T should be 2.015. And remember, only positive because we're only looking to the right. Our little arrow pointing to the right here, we're only looking at the right side of the curve. So we are only looking for a positive value. So that's our step 2. Step 3, we don't have to redo. We didn't have to redo the prep work. Again, the data didn't change, so we know the calculations are going to be the same. So we just saw that the sample variance of different scores was 30, that the estimated standard error was 1, and that the t-statistic was 3. Again, same, oh, I'm sorry, that was sums of squares. See, that's what I get for trying to do it from memory, huh? Variance was 6 points. Sorry about that, everybody. Variance was 6 points. Error was 1 point. Our t is 3.00. Again, same values as before. We look at our roadmap over here, and again, we are in that critical region. We are in the shaded areas. So we know for step 4, the decision is going to remain the same. We're going to reject the null. And in APA, it's going to look also exactly the same. A t of 5 equals 3.00, semicolon p less than 0.05. So that is the two-tailed version. I'm sorry, that we did the two-tailed before. This is the one-tailed version of the same problem. So no real surprises in that switch. So we've got a few topics left to cover in this chapter, and of course we'll get to those in the coming videos.